Hello. Is the screen is visible to you, all of you?
Yes, sir.
Check it once again. If anything is missing, you can let me know. Is it visible?
Yes, sir.
Yes, sir.
Okay. So we have already started the moving iron power factor meter, actually. Moving iron power factor meters. So three-phase moving iron power factor meter, yesterday class we have discussed. Now we'll go for the single phase. See, you look at the diagram carefully. This three-phase diagram, you look at the carefully. A1, A2, A3, three fixed coils are connected here. Now one phase to another phase here. A1 is connected to phase 1 and 2. A2 is connected to phase 2 and 3. Sorry, it is connected to phase 2. A3 is connected to the phase 3, connected through a current transformers. But when you go for the single phase, see here, A1, A2, all three phases, three coils are there, three phases they have connected. This is for the three phase. But when you will go for the single phase, you can check the diagram of this one and you can compare with the single phase diagram. This is the single phase diagram. This is the single phase diagram. Is there any difference between single phase and three phase moving iron power factor meter? You can observe the difference. What is the difference here? Anything is changed? Is there anything change or not? I'm asking to you peoples only. Both the diagrams are same, or is anything changed here? No, or any difference is there? Is it audible?
Yes, sir.
Tell the answer, no, then. How will study then?
Coils are fixed.
Which coils are fixed? There is no much
A1,
difference
A2, A3.
between, there is here also coils are fixed, there also coils are fixed only. The coils are not at all movable. The coils are not at all movable. All in the moving iron instruments, whatever the fixed coils only we are using here. But for the three phases, we have used three coils. Here actually for the single phase, we can use two coils also, but they have used the same structure here. The structure is same here only inside, but the supply changed. Instead of three phase, they have given a single phase supply to the each coil. Same supply, phase neutral, phase neutral, phase neutral they have. But the given supply is connected with different types of loads are connected here. Now different circuit elements are used here. For a coil A, we have connected its resistance R in series with coil A here. See here, R is connected here. The coil A is connected in series with resistance. Coil A2 is connected a inductance in series with the coil A2 here. The resistance is connected to coil A1, inductance is connected to the coil A2, and capacitance is connected to the coil 3 here. So all three coils are connected different circuit elements, that is resistance, inductance, and capacitance here. So this circuit, it acts as a RLC circuit. RLC circuits it is going to act. Because of this variation, if the power factor, the angle of deflection will changes based on the inductive load, capacitive, resistance, and all the things, the magnetic field produces here will be changes. Because the current will changes here for the inductive load, capacitive load, leading power factor, lagging power factor is there. Yes? Yes or no? For the inductive load, the current leads the voltage by 90 degree. For the capacity load, current leads the
Current
voltage.
lag.
No. For the inductive load, current lags the voltage by 90 degree.
Yes, sir.
But for the capacity load, current will leads the voltage by 90 degree. For the pure one, we are asking here, no. Is this pure capacitive load is connected here? No, it is a combination of resistive, inductive, and capacitive here. No, all three are connected. We cannot say that one the current is leading or lagging here. We should not identify that one, because depending on the load Rx, XL, and XC, it is going to depend here. If XL is greater than XC, then current lags. If XC is greater than XL, then current leads. Like that, we are going to discuss here. Before that, so you consider that the current flowing through the coil 1 is A1 is I1 current is flowing here. Now current flowing through the coil A2 is I2 is flowing here. Now current in the coil A3, I3 is the flowing here. See here, A1, A2, A3, all these three coils are 120 degree apart here. No, in the manner of 120 degree difference we have placed in all these coils. Yes.
Yes, sir.
So this one here, I1, I2, I3 here. No, I1, I2, I3, we have considered, we have jointed here. No, 120 degree apart only we have joined. 120 degree apart only we have joined here. But here the alternating field we have used here means one time this will act as positive, another time this will act as a positive here. For positive half cycle, negative half cycle. Yes, here for the positive half cycle, this will be act as positive, and for the negative half cycle, this will be act as positive, and this one will become negative and positive. But for that reason, what we are going to do, for the inductive and capacitive, there is no change in that induct positive and capacitive reverse here. But for the resistive load, what we will do here only one thing we are doing here now, the terminals will be reversals for the resistive connected terminal. Before reversal of connection of coil A1 here, now A1 coil terminals, we are going to make the reverse here now for the measure the operating here. Now what is the power factor we have to measure here? So listen here now. So we are not considering separately, we'll consider that one. It is not a pure inductive, pure capacitive, pure resistance here. All are combined here now. So I will consider which current is flowing here now, I1. In which coil it is flowing here now? A1 here now. Yes.
Yes, sir.
Okay, A1. The terminal reverse हो गए तो ये 120 degree difference हो जाएगा. All the terminals are reversed. Here for the positive or negative here no. This is 120 degree apart. A1 is 120 degree apart. Sorry, I1 is 120 degree apart from I2. I2 is 120 degree apart from I3. I3 is 120 degree apart from I1. But before that one, what will happen? The current flowing through the A1 coil is I1 here. No, I1. So the I2 is current is lagging or leading here now. I2
Current
should
is lagging.
lags the I1 or leads the I1. I2 should be lags the I1. So I will draw the I1 here now. I will draw the I1 here. So without any reverses here. And I3 should be leads or lags the I1.
Leads.
I3 should be leads the I1 here now. So 60 degree, how much it is?
120.
120. That is the what they have told here now. Before reversal of the connection of coil A1 here now. There is no reversal here now. If I will make the reverse, this point I will connect here and this point I will connect here now, positive to negative, negative to positive. You remove this part. This after reversal, what will happen? Here the I1 term will come here. I will erase everything, just a minute. You will understand later that exactly. So this part, don't consider this part. I will make this one as I1 here now. So I1, I2, I3. Here I1 to I2, how much angle is there?
Sir, the diagram ची slide दिसते.
Diagram ची slide मध्ये है ना सगळं हे.
Okay, sir.
द डायग्राम चे साइड मध्ये राइट साइड जूम किया होगा शायद आप, ज्यादा स्लाइड करो थोड़ा.
ओके सर.
इन द डायग्राम स्लाइड ओनली बाजूला फेजर डायग्राम है बघा. देखा क्या? दिख रहे क्या नहीं वो बोलो. फेजर डायग्राम इज विजिबल. डायग्राम स्लाइड मध्ये फेजर डायग्राम है.
Yes, sir. It is visible.
See here, this one before reversal of the terminal, so 60° I2 lags and 60° I3 will be leads I1 here. But after reversing the terminal of the A1 coil, what will happen? This will become here, the I1 will come here. I1 will come. Now, can you tell me what is the difference between angle difference between I1 and I2? 120°. It is 120°.
Yes, sir.
Here 60 plus 60, how much it is?
120.
So I2 to I3, how much? 120° away. Next here 120° here. So our system, it said that all the phases should be, it acts as a three phase only now. It is acting
Yes.
as three phase. So the operation of the single phase moving iron power factor meter is same like a three phase. Only the terminals of the A1 coil we have to make that one as reverse here. That's it. Before reversal, the angle will changes here now. Before reversal, the angle will changes, but after reversal of the terminal, it will, the operation will be same like three phase operation they have to here now. The same thing we have written in this explanation here. The slide will change or not, you check it once again. Slide is changed.
No, sir.
Still you are seeing the diagram only.
Yes, sir.
Yes.
Now.
Yes, sir. Now it is
Okay.
changed.
A single phase power factor meter based upon the principle outlined above is possible if we provide three fixed coils displaced by 120° in space. So three coils we have used, A1, A2, A3, we have used 120° apart, and we have fixed coils we have considered. These coils are connected through impedances through the lines as shown in the figure. Impedances we have considered over the R, Z equal to, impedance means Z equal to R plus JX. X may be, it may be capacitive reactance or inductive reactance, we can call that. The values of resistance R, inductance L and capacitance C are chosen so that current in coil A1 is in phase with line voltage. Okay, we will choose the L value, C value, R value. Whatever the value of you will choose for the resistance, it will not depend, because the current flowing through R is connected to the coil A. Current flowing through the coil A is always in phase with the line voltage. Single phase we are using here. But current in coil 2, A2 lags the by 60° and current in coil A3 leads 60° here now. This is the diagram is visible now.
No, sir.
Diagram is not visible.
No, sir.
Now.
Yes, sir.
Okay.
Yes.
I will put like this only, better option. I will not make full screen because it is. Okay, here, see here, I1 we are using here. I1 is in phase with the voltage, line voltage. So line voltage term we can draw like this here now. This is the line voltage V here. V we can write here. Voltage and current I1 both are in phase here. Comparing with this one, supply voltage. So I2 is lagging the voltage or leading the voltage?
Lagging the voltage.
I2 lags the voltage by 60° and I3 leads the voltage by 60° here. Same thing they have written in the explanation here now. Same thing we have written in the explanation here. The C chosen coil A1, current in the coil A1 is in phase with the line voltage but the current in coil A2 lags 60 degree and current in the coil A3 leads by 60 degree. So this is the one part. Okay, next, the connections of coil A1 are reversed with respect to the connections of the other coils over there. So with respect to the other coils, the connections of R1 will be, R coil A1 will be reversed in the three coils are so that the currents in the three coils are 120 degree out of phase with each other. Out of phase means not in phase. When we will reverse that one here. So the coil P is excited in the whatever in the iron core, the coil P is there here. This one, this is the coil P. Inside that two vanes are there. Based on these two vanes are 180 degree apart. So coil P, which is connected to the spindle and to a pointer here. Now, whatever the deflection is there, angle difference is there, that much here the difference or deflection will be shown here. Now, so what the once the angle is displayed, so theta equal to 5 we have to shown here. Now, that is the same operation of three-phase counting. They have told the P is excited by the line current. The rest of the arrangement is similar to that of described in three-phase wattmeter. They have told here. Three-phase wattmeter nahi hai, three-phase power factor meter we can call that. Three-phase meter directly I will write only three-phase meter here. So the fixed coil assembly consists of fixed coil क्या क्या consider करते हैं A1, A2 and E3. Both have, all three have equal currents for each displaced, each phase is displaced 120 degree. If they have equal currents, then they are displaced by 120 degree in time. Since the coil axes are displaced 120 degree in space, the revolving field is produced, which makes the system behave similarly to that for balanced three-phase supply. Okay. This is also applicable only for the balanced load. For the imbalanced load, we cannot measure the power factor. Different meters are there. So this one single phase power factor meter we have discussed here. Whatever these two vanes are there, they will give the deflection of the angle deflection they are going to display, which is directly connected to the pointer through a spindle here, which will give the exact power factor it is going to give over there. So it completes the power factor meter. Only one and advantages, disadvantages are there. We'll discuss. It has some, the moving iron system has some advantages and disadvantages. The slide is visible. Advantages, disadvantages slide.
Yes, sir.
Yes, sir.
Okay. So the advantages are the working forces are very large as compared with the dynamometer, dynamometer type over there. That dynamometer, it doesn't have three coils and all the things here. Here three fixed coils is there, and inside that one coil P is also there. So whatever the forces are there, those forces are more as compared with the dynamometer, we can say that. And one more thing, we are using the moving iron instrument, but all the coils are fixed here. The coils are fixed only A1, A2, A3. Yes. So all the coils in a moving iron instruments are fixed, and the reform, the use of ligament is eliminated. So moving part रहते हैं उसको performance check करके उसको use करने का, ligaments means whatever the movement is there, there is no parts or so because of the moving, some ligaments are parts, brushes, we cannot change that. So there is no moving, all are fixed only, we can call that one here. The scale extends over 360 degree. For the single phase also we are using for the 360 degree extensions. Yes, 120, 120, 120. How much degree it is?
360.
360 degree. Over 360 degree we are extending here. These instruments are simple and robust in construction. They are comparatively cheap as comparing with dynamometer type instruments. So these are the four advantages of moving iron power factor meters. And the advantages are there, but it has some disadvantages also here. Here, the vein we are using here now, that is moving iron. Iron part means some losses are there. Yes?
Yes, sir.
Because the current is flowing in the moving coil, then some losses are there, means some errors will come over there. Because of that, eddy current losses, hysteresis loss. So they are less accurate, we can call that one here. Errors are introduced in these meters owing to losses in iron part. These losses are depending upon the load and the frequency. they are less accurate than dynamometer. The cheap and robust, but the accuracy is less as compared to the dynamometer, they are going to call them. And the calibration of this instrument will be affected here now by variation in the supply frequency, voltage, and waveform here. It is also depends on the frequency. If the frequency is varied, then the accuracy or calibration will be varied over here. You can say that. So these are the some advantages and disadvantages of the moving iron instrument. The last topic of this chapter is frequency meter we have to discuss here. So power factor we have measured, but the frequency we have to measure or not? For the measurement of frequency, Indian standard frequency is 50 Hz. But according to that, we have to measure the frequency also. For that reason, the Whitson has derived one meter. That name came for that meter is Whitson frequency meter. To measure the frequency, he has derived one circuit that is called Whitson frequency meter circuit. We can call that one here. The slide is visible?
No, sir.
Whitson frequency meter. Now?
Yes, sir.
Okay, we'll keep like this only. What happened? I don't know. Okay. The definition of this Whitson frequency meter, the Whitson frequency meter is a moving iron instrument. This is also here also we are using a moving iron instrument only, used for the measuring. What we have to measure here now, the name itself, it indicates that frequency, unknown frequency or frequency we have to measure here. So the frequency meter consists here, it consists of one inductive and one resistive coil. It is consist here. One inductive coil, another one is resistive coil. It consists. When the frequency will vary, then the inductive and resistance is nothing but impedance only. We are going to call that one. Impedance only we'll call, na? Yes. Combination of resistance, inductance, capacitance. So when the frequency will vary, then the current flowing through the inductive coil, resistance coil will be vary over there. Based on that, we are going to measure the frequency here. Now, based on the current change in the coils, based on that, we are going to measure the frequency here. Now, when the frequency meter, it consists of one inductive and one resistive coil. When the frequency of the signal varies from standard frequency to the very standard frequency, say, then the current distribution across the coils become changes. So we can say that one, the frequency changes means current in the coil will changes. So obviously by measuring the current, we can identify the frequency. Yes or no? By considering if the frequency changes, then current in the coil will changes over there means. So we can measure the frequency with respect to the current also we can measure over there. So the working principle directly they have told here now. The Whitson frequency meter works on the principle that whenever the frequency of the circuit or signal varies, the distribution of the current in the inductive and resistive circuit of the meter changes over there. In the other words, the change of frequency causes in the inductive impedance of the circuit, because of which variation occurs in the distribution of the current in the parallel paths. See, listen carefully. We have to understand that only one thing here now. If the standard frequency is there, then the current flowing through the inductive coil and resistive coil both will be same. All the coils, both the coils, it will be same. Okay. If the frequency is not standard, other than standard, then current distribution in the inductive coil and capacitive coil are both the coil A and coil B. It will changes over there. That is the one point. Based on this only, we are going to measure the frequency meter. Is it clear? Working principle?
Yes, sir.
So it is completely depends on if the frequency is normal, then current flowing through both the coils will be equal. If frequency is other than the standard, then current distribution will changes for the each coil over there here. I will show the diagram, and based on that diagram, we'll explain here. The construction they have written here now. This is the diagram. Just a minute. Roll number 16. How when you are joining over there? See here. Is this visible? The diagram is visible.
Yes, sir.
Okay, I will make it full screen now because I will not change any slides, because in this diagram only I will explain the construction, I will explain the working principle, means working principle and everything here. Okay. See, it is like a earth tester and megger. The diagram is looks like that only, na?
Yes, sir.
Yes. See here. Here, two coils we are going to use. Both the coils are connected in perpendicular to each other. Yeah. See here, the coil A, it is coil A we have considered here. This one, the cursor, I will take the spotlight here now. The coil A we have considered here, this one. The coil A and coil B, whatever this horizontal part is there, that is coil A. Vertical parts are there, that is called coil B we have used here. Yes. Is it visible? Blue color lines and white color. It is there
Yes,
or not
sir.
here? So
Yes, sir.
here two coils are there. Both the coils are connected perpendicular to each other. Perpendicular to each other here now. So this is only one coil only. The axis of this coil A is horizontally connected. Coil A is horizontally connected. So the axis, reference axis we have considered here. Coil A reference axis is this one here. And coil B is connected in vertically connected here now. So that coil B is connected from here to here. So coil B reference we have taken here, now axis of coil B here. The dotted line indicates that one. The intersect of coil A reference and coil B axis here now, in that place the spindle is there, and that spindle, the pointer is connected here now, which is going to the magnetic needle is there, or which is going to the pointer is connected here now. The pointer is going to deflect the value here now. Frequency is normal or higher or lower, we are going to identify here. We are going to identify. Is this clear? The coils are connected in perpendicular to each other. Each coil, two coils are there, coil A and coil B here. Is it clear?
Yes, sir.
Yes. So next, here 4 elements we are going to use here. Now this is like a filter we are going to use. This inductance, total inductance, like a filter we are going to use. This one you leave it, don't consider now here. Other than this, RA, RB, LA, LB here now. So 4 elements we are using, 2 resistance, 2 inductance here. So what will happen? The resistance RA is connected in series with the coil A here. Now this is the coil A. In series with coil A, the RA is connected, and LB is connected in series with the coil B here now. See here, listen carefully. RA is connected in series with coil A, and LA is connected in parallel with coil A here. Here the coil A is inductance A is there. Here the coil A is there. Both are in parallel now. Both are in parallel. So the resistance RA is connected in series, and inductance RL is connected, LA is connected in parallel with coil A here. These two terminals, the coil A you consider, in a coil A, RA is connected in series with coil A, and LA is connected in parallel with coil A here. These two terminals are over now here. RA is connected in series, LA is connected in parallel with coil A. Okay. Next, similarly, the inductance LB is connected in series with the coil B. This is the coil B. It is connected in series. Means I say straight line better A. Is it connected in series only? The coil B, is it connected in series? Is there any junction here? No, no. It is a straight line only. The LB is connected in series. The inductance is connected in series with coil B. And what about RB? Comparing this one, RB is connected in series or parallel? It is in this place here. Instead of this, we can take here also. If we have taken here, means it is connected in parallel or series. Just for understanding purpose, I am telling that. Just assume that when it is not there, both are same only. Where we can connect here. Here the RB is there. So RB is connected in parallel. Here the coil B is there. So RB is connected in parallel with the coil B. Yes or no? Hello, is it audible?
Yes, sir.
So only one thing you have to understand here. Here the RA is connected in a coil A in series. RA is connected in series with coil A, but LB is connected in series with coil B here. So एक coil को inductance series में है, another coil को resistance series में. Is it understand now here? The connection diagram, the construction we are telling here now. The resistance RA is in series with coil A and LA is in parallel with coil A. RA and LA. RA series में, LA parallel में. But considering for coil B, LB is in series with coil B, but RA resistance is in parallel with coil B here. Here also in the reverse order we have connected here now, and the coil A and coil B both are connected perpendicular to each other. One is connected vertically, another one is connected in horizontal manner. We have connected here. Is it clear now? This is the construction of the Wilson frequency meter here. Is it clear? Or can I read the slide also? If you want, I will read that one also. Nothing to worry. The slide is changed or not?
No, sir.
No, sir.
Okay. When the supply is given to the frequency, just a minute. Construction chain. Construction is here. The meter consists of two coils. Two coils are connected, which are placed perpendicular to each other. Both are connected to perpendicular to each other. The resistance RA is connected in series with a coil A, and inductor LB is connected in series with coil B here. See here, coil A के साथ series में कौन सा connect है? RA.
RA.
But coil B के साथ series में कौन सा connect है? LB.
LB.
So the inductor LA is connected in parallel with coil A. Here LA is connected in parallel with coil A, but the resistance RB is parallel with coil B. RB is connected in parallel with coil B here.
Coil B.
Okay. The meter has the soft iron pointer and the magnetic needle, which are mounted at the center of the coils. The inductor L is connected in series with LA, RB, and L reduces the harmonics. Just like I told that one, it acts as a filter. Harmonics reduce करने के लिए. Thereby reduces the error of the instrument. L is used for the just like a harmonics here, no, and LA, RB, it is connected in series over there. Is it clear? Construction? Construction is clear?
Yes, sir.
Okay. Next, when the supply is given to the Wilson frequency meter, the current starts flowing into the coil A and coil B. Supply दिया तो current दोनों coil में जाते. Yes?
Yes, sir.
Here only. When we'll switch on the supply, these are all here. Some current will flow through the coil A and coil B here now. So current will start to coil A and coil B. But both the coils are connected perpendicular to each other. Yes?
Yes, sir.
Both the coils are connected to perpendicular each other. So perpendicular magnetic field will be produced over there or set up over there here now. The perpendicular magnetic field set up in the coil because of the current over there. Because of the current flowing through that coils, perpendicular magnetic field will be produced here. Now, the magnitude of the field depends on the current passes through the coil. The magnitude कैसे depend रहते हैं? Current flowing through the coils, coil A and coil B. Both the coils current कैसे flow हो जाएगा उसके ऊपर depend है. Okay, just imagine that the current at the normal frequency, the frequency is normal here. No, the frequency is normal. So current flowing through the coil A and coil B will be equal or different over there. Normal frequency means if the normal frequency is there, then current flowing through the coil A and coil B should be equal over there. The coil A magnetic field and coil B magnetic field will be perpendicular to each other. So current flowing through RA, LA, RB, LB should be equal, or same current is flowing over there. So in the both the coils, then whatever the field is set up by a coil A is equal to coil B. So we can say that one, the normal frequency is there here. The normal frequency is there. Suppose instead of normal frequency, if the frequencies increases over there, if the frequencies increases over there, then what will happen? The current flowing through the RA and RB will be same because the resistance will not change. But the frequency change means the value of LA and LB will be changes. The inductance value will be changes over there. So depending on what will happen, the impedance of the coil A will be decreases over there. Impedance of the coil A will be decreases over there. So impedance of the coil A will be decreases means what will happen? Impedance of the coil A will be increases over there. So then the current impedance is inversely proportional to the current. Yes?
Yes, sir.
Impedance is inversely proportional to the current. So current flowing through the coil will be decreases then.
Yes, sir.
Current flowing through the coil A will be decreases. Then the maximum current will flow through the coil B over here now. So because of this coil B current is maximum, so the coil B magnetic field setup will be high or strong magnetic field, we are going to tell that one. So on that situation, whatever the pointer is there, that magnetic needle, it is going to shift over there and it will show to the higher value here. The pointer will shift to the higher magnetic field here. Higher magnetic field. If the frequency is lower, then what will happen? The coil B magnetic field will be increases, current flowing through the coil A will be decreases over there. So coil A current will be increases, and that situation what will happen? It is a reverse order here. Only one you can discuss that one. Higher or lower you can discuss. Opposite to that one, dead opposite to that one, it will give the other value. So a same thing we have explained here now. See here. When the अभी मैंने explain किए वालों को same link होना है इधर. Okay. When the supply is given to the Whitson frequency meter, the current starts flowing into coil A and coil B. Both the current coil में current flow हो जाएगा. Next, the perpendicular magnetic field will be set up in the coil because of the current here now. So the magnitude of the field current depends on the current passes through the coil over there. Field depends on current, how much current will flow through the coil over there. So the magnetic field of both the coil A and coil B acts on the soft iron and the magnetic needle. The position of the needle depending on the relative magnitude of the magnetic field acts on that. Whatever the needle is there, that position will be depends on the relative magnetic of the magnetic field. But the magnetic field is depends on what? The magnetic field will be depends on what? Current passes through the coils. So the magnitude of the field depends on the current passes through the coil, and the needle is depends on the relative magnetic field of the coil. So directly we can say that one, the needle depends on the position of the needle depends on the current. We can call that one current passes through the coil. Yes.
Yes.
Okay. When the supply of the normal frequency, remember here now, when we will give the supply with normal frequency applies across the meter, the voltage drop of the same magnitude occurs across the reactance LA and resistance RB. Both because LA is connected in parallel with the coil A, RB is connected in parallel with the coil B. Yes. LA is connected in parallel with the coil A. Yes. LA is connected in parallel with coil A and RB is connected in parallel with coil B here. Hence, equal current passes through the coil A and coil B. The current flowing through the coil A and coil B will be equal for the normal frequency. Same explain किए. Yes. With the diagram, I have explained same thing only. If the current flowing through coil A and coil B will be same, then there is no change. The frequency will be normal over there. Okay. See here, one more explanation. Same for the normal frequency. The meter designs, this meter designs such a way that when the normal frequency passes through the coil, normal frequency pass ho gaye to, then the voltage drops across LA. LA means which is connected in parallel with coil A, LB which is connected in series with coil B, RA which is connected in series with coil A, RB which is connected in parallel with coil, in series with coil B here now. So LA, the voltage drop across the LA, LB, RA, RB remains same. The normal frequency means the voltage drop across LA, LB, RA, RB will remain same. Thus, the magnitude current passes through the coil here. Now, in this situation, the magnetic needle makes an angle of 45 degree concerning the coil, and soft iron needle places at the center of the scale. Sorry, because of the due to the internet problem, it was disconnected over there. The screen is visible. Hello. Hello.
Yes, sir.
Okay. So the needle here, by seeing the diagram, you just check the diagram here now. See here, this needle and pointer, how much difference is there? 45 degree almost. Here, this line to this line, how much degree is the difference? Reference plane, you consider that one here. This is the reference plane. Okay, the pointer and reference plane, how much degree is the difference?
90.
90 degree. Half of the 90 degrees?
45.
So 45 either and 45 either hai. So needle is always 45 degree difference. It is going to maintain the pointer over there here now. So operating this needle only, magnetic, it is depends on magnetic field only. So depending on this needle only, the pointer is going to reflect over there. So that one only they have mentioned here, that here in this situation at the normal frequency, the magnetic needle makes an angle of 45 degree concerning the coils, and the soft iron needle places at the center of the scale over there. So the needle places at the center of the scale. We are going to, the pointer is going to place at the center here. Now the pointer is at the normal frequency here. Suppose if we will apply higher frequency, higher than the standard frequency, when the high frequency passes through the meter, frequency high ho gayi, to what will happen? The reactance LA and LB of the coil increases over there. Reactance increases means impedance will be increases. Yes.
Yes, sir.
If the reactance increases means voltage drop across LA is nothing but V equal to I into XL. I into XL, we are going to call that one. Voltage drop across this one. I equal to V equal to I into XL. Yes. I into X. मालूम है क्या?
Yes, sir.
So if X reactance is increased, then voltage drop will be increases over there. Yes. So impedance will be changes over there. So based on that, the reactance LA and LB of the coil increases, and the RA, RB remains same over there. The resistance will not change over there. Only the reactance value will change. Because of this, the inductance increases the impedance of the coil. Because of this inductive coil, inductive LA and LB, it will increases the impedance of the coil. Impedance is nothing but how? Z. Z is the combination of resistance and reactance. Z equal to R plus JX. मालूम है ना formula? Z equal to R plus JX. All of you know. R is nothing but resistance. X is nothing but inductance here now, or reactance we will call that one. It may be inductive reactance or capacitive reactance. So the inductance LA and LB increases means then the impedance of the coil will also increases here now. We know the formula. We know the formula. Z equal to R plus JX. R plus Jx मालूम है आपको. Okay, x is nothing but this is inductive reactance here. R is constant. If Jx is increased means Z will be increases or decreases. If XL is increased, then what will happen in the Z?
Increases.
Increases here now. Same thing is happening here now. The inductance increases, then the impedance of the coil A also increases over there here now. So the impedance means the opposition offered by the circuit in the flow of current here now. Impedance is nothing but combination of resistance and reactance. It is means which will opposes the current over there. So the magnitude of the current coil A, if the coil A impedance is increased, means what will happen in the current? Current flowing through the coil will be
Decreases.
decreases here now. So the magnitude of the current of coil A decreases over there. So the field develops of coil A also decreases here now. Because of that, what will happen? The more current flows through the coil B because of the parallel connection here. Now coil A current will be decreases means, but the maximum current where it will flow? The parallel path it is going to flow. Parallel path is connected to the coil B here now. So because of coil B, the maximum current will flow because of the parallel connection with the coil A here now. So the magnetic field develops in the coil B becomes stronger than coil A. So coil A का current decrease हो गए तो magnetic field produced in the coil will be decreases obviously.
Yes.
Coil B magnetic field will be stronger. So coil B magnetic field develops in the coil B will be stronger than coil A. Then the magnetic needles aligns themselves parallel to the axis of the strong magnetic field. The pointer will deflect towards the coil B or strong magnetic field. Strong magnetic field की तरफ move हो जाएगा. So that is nothing but here the pointer will be moves to this side here. No, higher side it is going to move over there. Similarly, if the frequency, lower frequency will passes through that one over there. Lower frequency passes हो गए तो क्या हो गए? Coil B current will be low and coil A is stronger than the magnetic field produced by coil A will be stronger than coil B. On that situation, the pointer will move to the coil A side, opposition side. Which it is similarly vice versa for the lower frequency also we can tell that one. Is it clear? Is it clear? If coil B magnetic field is stronger than coil A, then the magnetic needle will be moved here. Now, if coil A magnetic field is stronger than coil B, then the this needle will move to the lower side here. Is it clear? So it completes the second unit here now. With when the frequency of the measurand or signal reduces the normal value, the opposite action takes place and the pointer deflects towards the left side. It is going to deflect over there. Yeah. So it completes the second unit and will continue in the next class. The third unit will be continued over there. Okay. All of you already the PPTs are uploaded in the drive. We can download it from there and you can read it. I have the meeting now at 4:30. What is the time now? My mobile it is showing 4:25. Any doubts? The second unit is over now. I think all of you have written the assignment of the first unit. Be ready for the test. Unit test 2, chapter test 2. I may take tomorrow or day after tomorrow. आवाज आ रहा है क्या? Is it audible?
Yes, sir.
Yes, sir.
So it completes the second unit. What I am saying, maybe tomorrow or day after tomorrow, within 2 to 3 days, I will take the chapter test. Be ready. Be ready for the chapter test 2. You can download the MCQ booklet is already with you people. Prepare well and be ready. Maybe tomorrow or day after tomorrow, I will take the chapter test. For that reason only, be ready for the tomorrow. Okay, I'll stop here only and we'll continue in the next class. So the second unit was very bigger unit actually. Yes or no? So many days we have discussed the second unit. So many meters are there. So comparing with second unit, third unit is bigger, that vast syllabus than second unit. Potentiometers will come, different types of bridges will come in the third unit. Once the third and fourth is over, then it will not take much time for the 5 and 6. Okay. So once we'll start the third unit, remember that one. After starting the third unit, it may be half of once the potentiometer over means we'll planning for the ISC in the up to December 10. ISC 1 will be there. Be ready for the ISC 1. ISC 1 will not be for the MCQ type questions. MCQ type questions plus 4 marks question will come. You have to write and you have to upload. For that reason, be ready for the give the ISC also. Long lengthy questions will also come over there. Okay, I'll stop the here only.